All right, let's read the their work. So I have disagreements. We had signed all of the problems up to number 6. So today we're looking at 7, number 8, number 9, and I'll tell you what my work is going to be. So we're working on page 55. Starting with 7, 8, and 9. So the question in number 7 is asking, is there any positive number b so that the expression log base b of 0 makes sense?
No,
Why not?
because no number squared is going to be 0. Because if you do 0, 0 to the 0th power is 1, and any other number to the 0th power is 1. So the closer you get is 0.
She's saying no, there's no x, because there is no way that I can raise a number to an exponent and get 0. We get closer and closer to 0, but that quite can't touch 0. Because any number that's not 0 to the 0th power is 1, and then it starts to become a decimal smaller than 1, but never quite gets to 0. And if you actually did your homework, 4e, 5e were examples of it. Number 8 question is there any positive number b so that the expression log of b is -1, log base b of -1 will be equals to? Because then again, this question becomes, it's impossible for me to have a number that is positive and raise that to a power and get a negative answer. If I keep multiplying a positive number by a positive number by a positive number by a positive number, do I ever get to a negative? No, why not?
Because a positive times a positive.
So I only have one person in this room? I have way too many people in this room. If I multiply a positive number by itself over and over and over and over, do I ever get a negative answer? She says no. And I said, why? If somebody gave me a why, I can never get a negative. Because a positive times a positive is a positive because there's no negative. Only time I can multiply and end up with a negative answer, I at least have to have one negative value in it. So there's a reason that's not possible. Two different answers, two varying answers, exactly the same point. Questions? Anybody with a question? Okay. Number 9 is leading to today's work. So let's do number 9, and then we can come up with a property that we can generalize, because today's work is going to be built on number 9. So let's start with 9a. Problem A says the value of log base 2 of A plus whatever value log base 2 of 4 gives me. I need to show that that is the same as if I knew the log base 2 of 32. So we need to show that. Okay? So to verify it, we just put a question mark. And then we don't know if that's true. Right? Because it says verify. So let's prove it. We ready? So let's use what we know. Log base 2 of 8. I'm asking you, what power of 2 gives me 8, right? Because that's what the log is, what power. So what power of 2 gives me 8? 3. We all agree with that? Because 2 times 2 times 2 is 8. So this is a 3 plus, based on what we know, what power of 2 gives me 4? 2. Okay. So this is 2, right? We still don't know if they're the same, but let's check this out. What power of 2 gives me 32? 5. We did that before, right? So this is 5. Are they equal? Am I saying that? I'm going to leave that on the board and I'm doing B because I want eventually for somebody to go, I see a pattern. I see what's happening. You already see it? All right. Okay. Hold on, I got 2 folks seeing it. I need a little bit more. So let's do B. So problem B. Problem B says log base 3 of 9 plus another log base 3 of 9. I don't know if that is equals to the log base 3 of 81. So they want us to verify this also. So we don't know what it is yet. Let's put a question mark and check it out. You ready? What power of 3 gives me 9? 2. Okay. So if this is 2, this is also 2, right? Now, let's slow down. Those folks who said they already seen this, what should this answer be based on your generalization? 4. Why? Okay. 2 plus 2 is equals to 4, but what was the pattern we're looking at here? The powers? Say that out. It's multiplying the parentheses. Why are we multiplying the parentheses when there's an addition here? What did we just get from before coming to log? What unit did we just work on a lot before starting what power? We did a lot of properties on it. You took a test, you had a blue sheet, and you were using the term exponents. Right? And in exponents, whenever we have a multiplication, what did we do with the exponents? Whenever we had a multiplication, what did we do with the exponents? We added it, right? Start looking at that. Right? So they said we multiplied, so then because 9 times 9 is what? 81, therefore the sum of their exponents will be the same, right? But if we don't know that, we can just check here. 3 times 3 is 9. 9 times 3, 27. 27 times 3, 81. So again, check. Yeah, just check and see if it's short. Right? So, for example, you are home and your mom said, is the front door locked? And you say, yes. She's like, go check. It's like, go verify. What do? You go in there and you check and see, and you go back. So, exactly what we're doing here. We verify. Okay? Because they say it's true. So, we want to find out if they're saying the truth or not. So, we just check it. Questions? So, let me do an extension. If we just told me that we have a situation, because the generalization here now based on what they're telling us is that if I have a log of base a of x plus the same base of y, then I should write it as 1 log of x times y, right? Because we multiply, right? X times y, x times y. Okay? Now, if this is true for addition, what do you think will happen if we have a subtraction? Say that again? Why? Same reason, right? So she says, she sees a generalization that if I have a log base a of x minus the same base of y, that should give me 1 log of the quotient. Okay? So the only thing you need to know in this new session is to know the factors, because we got to break things up into factors. How many, what all multiplies to give me stuff? I'm going to break them up. Can I divide them and just use one log, okay? Or can I just subtract them? We're good? So the two properties I need you folks to write in your notebooks, because we're going to be referring to them heavily, are these two properties here. So we'll write them up here. So the log base A of x plus the log base A of y, the log base A of their product, and the log base A of x minus the log base A of y is their portion. Log base A of their portion. These are the properties of logarithms that we're going to be using in this section. Anybody with a question? So then, I need everybody to flip over to page 68. Page 68. So we're given a table of values. Okay? It says the log of x. If x is 1, then the log of 1 is 0. If x is 2, then the log of 2 is 0.301. Okay? And then so on and so forth. Okay? One thing I want you to first get is anytime we write a log, there is a base. If we don't write a base, then we assume the base is base 10. Okay? So all of that thing we're going to do a log base 10. That's the base that your calculator works with. When you see LOG on your calculator, it's saying base 10. We're good? So let's do problem A. It says we should find the log of 80. The log of 80. In that table, we don't have 80 for x, right? But do we have factors of 80 in there? What are they? 5 and what? 5 and 4? 5, 4, and 2. Okay, so it gives me factors that multiply to give me 80 from that table. Give me a set. So 5 times 4 is? I know what you mean, but I want you to give me everything. I know 5 and 4 and 2 we eventually get there, but how many 5s, how many 4s, how many 2s will give me there? Yeah, to give me the whole 80. So then again? 40 and 2. Okay, so let's do that way, because she wants us to break it around little pieces. So she says, this is the same I'm saying, the log of 40 times 2. Okay, because we have 2 in there, right? But do we have 40 in there? No, so let's try to break the 40 with numbers that we have in that table. What numbers combination in that table will give me 40? 5 and 8. Do we have 8 in there? Okay. So then this is the log of 5, 8, and this 2 that we had before, right? Everybody seen that? So now we have a multiplication. What did the property say when we have a multiplication? How do we write it as? Addition. right? The sum of the individual parts. So this is the log of 5 plus the log of 8 plus the log of 2. See that? So what is the value given to us for the log of 5 from the table? 0.6990. What's the log of 8? 0.9031. And the log of 2?
0.3010.
So then you just add all of those things up. That will be your answer. By the way, I could have also said 40 is the same as 16 times 5. Now I don't have 16, but I could write 16 as 2 times 2 times 2 times 2, right? So 4 of those pieces, right? And then say 4. Do the same thing. Questions? Anybody with a question? In order to do problem B, we're going to have a Michael Jackson moment. Do you remember the time? Okay? I told you last time we were here that whenever we have the log base x of x to the a, then the answer is just a because we have the base and the argument being the same. Okay? Because that question, we did that with the square root of 7 and all the other pieces. Log this is just telling me what power do I raise x to get that, right? And if you already told me that was a, well then it's just x to the a is x, right? Or x to the x is a. So what we want to do here is to keep this in mind. Whenever we have the base and this argument being the same, then our answer is just the exponent. I'm saying that because I already told you that the log without a base has a 10 written there that we don't quite write. Okay? So let's try 7,000. The log of 7,000. I'm going to rewrite this to see how many people will see this already. So this is the same as the log of 7 times 10 to what power? See that now? So this is a multiplication, so I can write them as the sum of the individual parts, right? So this is the same as the log of 7 plus the log base 10 of 10 to the third. We'll just write a 10 here also to keep it consistent. Do we know what the value of the log of 7 is from the table?
Yes.
What is it? 0.8451. Okay. 0.8451. Do we know what this value is? Do we need a table to find this value? Look at the Michael Jackson we just talked about. Remember the time. Do we need a table to find out what this value is? What's the value of this? 3. This is now log base x of x to the a. This is now a. Because these two things, 10 and 10, this is just a 3. Because it's asking, so what power do I raise 10 to get 1,000? Well, there's 3, right? Or if you like, those of you who don't like scientific notation, we've written this as the log of 7 times 1,000. It's the same thing, right? because this is just a log of 7 plus the log of 1,000, or the log of 1,000, saying what power do I raise 10 to give me 1,000, still 3. Questions? Right. That's the reason she should be right. Jackson?
Using my room, just living with that feeling that.
So problem C. Now we have to write that as a scientific notation because it's really, really, really small. Unless you're really, really, really good at finding what multiplies into decimals. Okay? The other day when we did scientific notation, when I introduced it, and I said you should have done that in science, we said all we have to do is move the decimal point. Alright? If we're moving it this way, we just add, count how many times we move it, have a positive exponent. If we're moving it back that way, it's a negative exponent. So what I need to do is to write the log of, how many zeros are in there? 4. Okay. 1, 2, 3, 4, 6. So with my decimal point, 1, 2, 3, 4, 5. So this is the same as the log of 6 times 10 to the negative 5th power. Because I moved this thing 5 times. There we go. Negative 5 times. All 5 times. See how that makes your life easy? It went from looking really complicated. So now it's a multiplication. What do we do again? We're writing it this way. So this is the same as the log of 6 plus the log of Do we have a value for the log of 6 in the table?
Yes.
Yes. Even if we didn't, we have a 2 and a 3, right? We could have written it 2 times 3, which is log of 2 plus the log of 3. So what's the value for 6? 0.778? 2. Okay. Plus, now again, referring back to, do you remember the time, the Michael Jackson moment, what is the value of this? Because it's not in the table, but we should know it, and that would be what?
Negative 5.
Negative 5. So minus 5. Whatever that value gives you. Anybody with a question? Well, it's the same thing, we just minus 5. Questions? Anybody need me to do the next problem, or you're ready to do your work? Do the next one? What's the next one asking for? So, well, yeah. If the next one says the log of 3 times 10 to the 27. So, the next problem says, we already done the scientific notation for you. How about you just finish the work? So, this is the log of, it says 3.0. I have a multiplication, so I'm referring to the first property, right? So, the log of 3.0 is just 3, the log of 3, plus the log of 10 to the 27. Just in case you forgot, that's the base we're working in. Do we know the value of the log of 3?
Yes.
From the table?
Mm-hmm.
Yes. Without the table, do we know the value of the log base 10 of 10 to the 27?
Yes.
What would that be? 27. So whatever this is, add 27 to it. So those would be 27 point whatever that 3 happens, right? Everybody seen that? So log base 10 of 10 to some power is just the power. We can do that with log base 2 also. Log base 2 of 2 to any power is just the power. Log base 3 of 3 to any power is just the power. Good? Questions? So your work for me is going to be on the problem set page. I think that's page 73. Number 1 and number 2. Number 1 has a lot of babies. It's like Flavor Flav. I don't care. Number 2, however, you should spend not more than 5 minutes on number 2, right? Because let's look at number 2, for example. 2a. What are you going to do with 2a? It says ready as 1 log, but it's an addition. So what do? We multiply. So the one answer is going to be log of what? 35. Why 35? That's 5 times 7 is 35. Let's see that? All right. Work with somebody closest to you. Those of you that I move, you can move back to the people I moved you from.